Let x sub 1, x sub 2, x sub 3, and x sub 4 be positive integers such that x sub 1 is greater than 1, x sub 2 is greater than 2, x sub 3 is greater than 4, and x sub 4 is greater than 5. Find the total number of ordered 4 tuples satisfying the integer equation x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 is equal to 2024. Express your answer in combination notation. This question was from the 2024 UP Math Major Circle's MATHirang MATHibay, which is one of the most prestigious math contests in the Philippines for high school students. The solution for this one is quite straightforward if you're familiar with the method of stars and bars, also known as the urns and balls or the sticks and stones method. I did a video about it a couple of years ago. It's an introductory piece about the method, and I highly suggest that you watch that to fully understand the concept behind it. And once you watch that, I think that this method should be, or this problem would be a piece of cake. But I'll discuss this as well in this solution, a brief overview about the method. Let's say we want to find the number of non-negative solutions for the integer equation a plus b plus c is equal to 5. Now basically, we can consider doing this, or we can consider the number of solutions for this one as finding the number of divisions of 5 stars. Because we have here total of 5, we can consider 5 stars. Now if we do some divisions, we call those divisions as bars. Let's put the bar here and here. If we count the number of stars in between or to the left or to the right of the bar, we get here 1, we get here 2, we get here 2. Which means that 1, 2, 2 is a solution for this integer equation. We can also place this elsewhere to generate other solutions. For example, if we put the bar here and then here, we get this as 0, we get here as 5, we get here as 0. So basically, finding the number of solutions for this one is just equivalent to finding the number of possible placements of the bars. So in this case, we have 5 stars and we have 3 variables, which means that we need 2 bars and 5 stars. So in total, we will have here 7 slots where we can position the stars and the bars. So we can think of this as simply assigning the positions of the bars. So since we have 7 slots here, the number of combinations taken 2 would give us a total number of placements of the bars. Note that once we fix the placement of the bars, we are essentially fixing the placement of the stars as well. So the number of solutions for this one is 7 taken 2. If it's not quite clear yet, I suggest that you watch a clear explanation that I did in another video. It's a longer one, but it's more juicy, and you'll understand and appreciate the method more. So moving on to the problem, we're looking here for the number of solutions for this one, given the constraints that x sub 1 is greater than 1, x sub 2 is greater than 2, and so on. To actually solve this problem, we will have to make use of some dummy variables. This is because the method of stars and bars for integer equations only work for all non-negative solutions. And for this one, we are not solving for the number of non-negative solutions. We are considering the number of solutions satisfying these conditions. Since x sub 1 must be greater than 1, the smallest possible value of x sub 1 would be 2. So our dummy variable for this one should be x sub 1 is equal to x sub 1 prime plus 2. And this is equal to x sub 1. Now this substitution allows x sub 1 to be at least equal to 0. And if it's 0, then the lowest value that it can get is 2. Get it? We can do the same for x sub 2. In this case, we will use the prime variable x sub 2 prime plus 3. We do the same for x sub 3 prime plus 5, and then x sub 4 prime plus 6 is equal to 2024. We isolate the variables on the left side, but I'll just write here the labels just to be clear. Now we isolate the variables on the left side. We get here the sum of the prime variables is equal to 2024 minus 2 minus 3 minus 5 minus 6 is equal to 2008. By the method of stars and bars, we have here 2008 stars, and then we have here 4 variables, so we need 3 bars. So for this one, this would be added 3, taken 3. We simplify this, we get 2011 taken 3. Therefore, the number of solutions that we're looking for here is equal to 2011 taken 3. And that's our final answer. So again, this method is known as the method of stars and bars. We just did this primed variable substitution to make the solution fit the requirement for stars and bars. I hope you learned something from this video. If you haven't subscribed yet, please consider doing so. Thank you for watching and see you on the next one. Bye-bye.